So this is the last part in chapter in lesson 3.4. It's about the sum and the product of polynomial roots. So if I have a polynomial of we know already if I have a polynomial of degree 2, it's minus b over a and c over a. But now here if I have a polynomial of degree 3, and if x1, x2, x3 are the roots of this polynomial, the sum of the roots that follow this formula, it's minus b over a. The product, it's minus d over a, and x1 times x2 plus x1 times x3 plus x2 times x3 is equal to c over a. Let's do an example for this one. So if I have this polynomial, f of x is equal 3x3 plus 5x squared plus 2x minus 4, and if x1 and x2, x3 are the roots of f of x, without solving the equation, it means without finding the roots, I don't need to find the roots. I need to find just what is the value of x1 plus x2 plus x3, x1 times x2 times x3, and this expression. So for the first one is very easy. I just need to follow the formula. So when I say x1 plus x2 plus x3, the formula is minus b over a. So who is first, to be on the safe side, the best way is to write what is a. So let's write what is a. What's happening here? A is 3, B is 5, C is 2. Sorry, guys. Okay, and D is minus 4. Let's erase the mess here. Okay, so directly, what is B? 5 minus 5 over 3. So directly I can write this, that the sum of the roots is minus 5 over 3. Now if I go to the second question, 2, what is the product of the roots? So I need to find x1 times x2 times x3. So also I can and follow the formula. For the product, it's minus d over a. So all what we need to do is to write minus minus 4, so it's 4 over 3. And I got the product. Now how are we going to find 1 over x1, x2 plus 1 over x1 times x3 plus 1 over x2, x3? So to be able to do this one first, I need to think about first, when I'm adding fractions, we need to add to have the same denominator. So my same denominator gonna be x1, x2, x3. So it means, what did I multiply by the first fraction? I multiplied by x3. So this one is x3 times 1. So it's x3 plus, I multiplied the second one by x2 plus x2, and the last one by x1. It means, as I have, it's s over p. It means it's minus 5 over 3 divided by 4 over 3. And we know that when I'm dividing by fraction, it means I'm multiplying by the inverse. So it will be minus 5 over 3 times 3 over 4. I can simplify, and my answer is minus 5 over 4. But now you're going to tell me, but miss, if it's not degree 3, let's say it's more than degree 3, do we have any rule to find the roots of the sum of the roots and the product? Yes, we have. So let's write here part, if it was here part 4, so let's write here part 5. I'm still having the sum and the product, so it's part, not what's happening to the mouse, part 5. The mouse is not working. 1 minute, let me just fix it. Okay, so part 5, that's it. I have the sum and the product of any polynomial. So let's say I have any polynomial f of x is equal an xn plus an minus 1 xn minus 1 plus till I have here a1x plus a0, and you need to be sure that an cannot be equal to 0. So what is the rule for the sum and the product? So if I want to find the sum, so if I have here, I have xn, it means I have n roots. So I have x1 plus x2, because we are talking about the sum of the real and the imaginary root, all the roots. So plus xn. So it's equal minus an minus 1 over an. So it's all the time minus the coefficient of the next degree. So if the degree that becomes after the highest degree. So it's this coefficient over the first coefficient. And what is x1 times x2 times x3 till this is times xn? It's minus 1 exponent n. So this I'm going to give me if it's minus or plus. Times what? The constant that I have here. So it's a0 over the first coefficient of the coefficient of the highest degree, an. That's it. So let's do an example for that, and and will be done from this lesson. So if I give you, for example, let's say f of x is equal, so this is an example, the last example for this lesson. Let's say I said you have, let's say, x4 plus x3 minus 2x2 plus 3x minus 2. So if I want to find the sum, so here it's x4, it means I have x1 plus x2 plus x3 plus, and I will mention again that the roots can be complex or real roots. So it's equal, so the sum is equal minus, and then I will take the one that is here, so it's minus 1 over the first coefficient 1, so it's equal to minus 1. Now, if I want to find x1 times x2 times x3 times x4, so it's equal minus 1 first exponent 4 times, I will take the constant, so it's minus 2 over the coefficient of the highest degree, so over 1, so the answer is minus 2. If you want, we can do one more example since I still have some more minutes. So we can do another example. Let's do one more example. If, for example, I can give you f of x is equal to x5 minus 5x4 plus 15x3 minus 511x squared and minus 4x plus 8. So if I want to find the sum of the roots, so I'm doing x1 plus till x5, so it's equal minus, I take this coefficient here, so it's minus 5 over the coefficient of the highest degree 2, so the answer is 5 over 2. And if I want to find the product of all the roots, it means x1 times x2 till x5, so it's minus 1 exponent 5 times, what is my constant here? It's 8 over the coefficient of the highest degree over 2, and my answer gonna be minus 8 over 2, so it's equal to minus 4. So that's it for our lesson. It's done. So you will watch later on lesson 3.4.